Hello and assalamu alaikum everyone. Today in this tutorial we will design microstrip patch antenna. So let's begin. First of all, a microwave antenna. So actually microwave antenna is made of RLC parallel resonance circuit. So for that I have put there a resistor. By the way, this is a window from where you can take place any equipment in your design window. I mean in this window. So first of all, I have put a resistor. Manually you can change its value. By default, let I choose it 40. By default, it is almost equal to 50. I mean it is 50. Now here you can see L is symbol of inductor, so I will take place inductor in parallel to this resistor. Okay, so if you see its inductance is 1 nano henry, so you can change it by double clicking it. So I am choosing it to 2. After entering it will be okay. Now I need to choose a capacitor. So here I place a capacitor in also in parallel with the inductor and resistor. You can see here. So by default the capacitance value by default the capacitance is 1 picofarad. So it is actually I think pico is 10 to the power minus 15, and nano is equal to 10 to the power minus 9. So it's mean inductance and capacitance value is very small. Okay, now I need a wire. So here is a wire. I will double click on inductor, then I will click on resistor, and then I will double click on inductor. Okay, I think this is not good, so I need to cancel it by default. By selecting end and by delete option it will cancel. Okay, by pressing escape wire will be end at that time. Okay, now I need to again select a wire, and I will click on that node, and then I will select this node, and after that I will select this node. Okay, now I will enter escape. So you can see wire is not connecting with any thing else. So this is let's suppose this is an microstrip patch antenna. It may be rectangular or circular, it's something else. Now I need to feed this microstrip patch antenna with the help of microstrip peel line. So actually microstrip peel line is made of the combination of inductor and capacitor. By the way, this inductor and capacitor will be in series. So I will select capacitor. Okay, now I will need to assign waveguide 4 to this. So for that I will select this option is which name is SP, is parameter simulation. So no, I will need to assign a guide for I will need to assign a generator in place of waveguide 4. So I will select this term, you know this. Okay, so this is a AC source which will provide which will provide AC electric signal to this speed line, and this speed line will deliver this will deliver that signal to this resonant circuit, and this this resistor will be used in radiation. Okay, now one thing more that I need is I will need to terminate this signal at this point. So for that I will use use a resistor, the same value of 50 ohm, and I will need to take place a ground over here. Okay, so first of all I will connect this AC source with this feed line, and this feed line, you know, that is connected with the patch antenna, and you know that in electrical signals in AC circuits we sometimes we need a terminator will actually terminate the incoming signal which is coming from AC generator or AC source. So for terminating these incoming signal, we have used here R2, which is actually a terminator, and its value is 50 ohm. One thing more, I think I should change this 40 ohm to 50 ohm, because according to maximum power theorem, source terminator or load resistance should be equal to each other, or source or transmission line or feed resistance should be equal to each other. Or in other words, I want to say that I need to take equal value of these two. So you can change its value from 50 ohm to 40 ohm to 42 ohm. Uh, it's your choice, but I think it will be more fine if you select other value 40 ohm, or you may select 42 value according to your need. So first of all I need to select this, I need to connect this resistor with this microstrip patch antenna, and you can see here a wire is selected. So I think I should cancel it by pressing escape. Now I will select a new wire. So you can see here wire is selected over here. Okay, now I will need to analyze this antenna in terms of S parameters. So for that purpose I will select S parameter over here, and from here you can change the starting and ending frequency for simulation purpose. So I will uh, select it from over here, or you can double click on it, and from here you can also change values, and you can also change the unit of any antenna by selecting hertz, kilohertz, megahertz, gigahertz, and up to terahertz. So let's take it I think I need to simulate it. It doesn't mean what is the unit of, and what is the unit in what it may be, I mean it may be in gigahertz or terahertz. It doesn't mean it doesn't affect the performance of antenna. So I let this in um, gigahertz, and I selecting it from starting frequency from 1 gigahertz and stopping frequency 200 gigahertz. And here you can say the number of points you can number of points you want to in your simulations, number of points or number of steps you want in your simulation. You can change according to your desire. So from here you can use sweep lane also, and parameters, s parameter, xy parameter. You can also change noise, and some other parameters are also are there, so you can change to there according to your needs. So in this case I just need to change the frequencies. So I have changed it from starting from stopping at the end point from 10 to 100. So now I'm applying to OK, and now I will need to simulate this antenna. So for simulation purpose, you will select this option. So when you pressing this, after a few minutes your antenna will be simulated. And okay, so I think it is now simulated. Now I will need to view the S parameter in 2D plan. So for that purpose I will select select this window, and I will drag it over here. Okay, now I will need to select S11, which S11 which is representing S parameter, and after selecting this I will add. So I need S parameter or reflection coefficient in dB scale, so I will select dB. Okay, so if I will pressing if I will select OK, so now you can see here this antenna resonate at almost 7.441 gigahertz. Okay, so now I will need to change this resonance frequency to something other, to change this to something else. I want to bring it to up to 15 gigahertz or 5 gigahertz. So inshallah in next video we will discuss how to increase or decrease this resonance frequency, to how to change this resonance frequency. So inshallah in next video we will discuss, and we will also discuss how to bring this S parameter from almost minus 19 dB to something below value. So inshallah we will discuss in next video. Bye bye.